Hi, I'm just going to go over problems 16, 25, and 26 here from the 14.2 homework. We'll start with problem number 16, which is up on the screen here. And we're given a set of data, and it asks us to find the mean, median, and mode. So first of all, I'd like to just refer to the textbook so we can just kind of see where this is covered in the textbook. So I'll click on this button that brings up the textbook. It's just this button that says read it, and that will bring it up in a separate tab. And it takes us right to section 14.2. And what I'd like to do, these videos would be helpful if you haven't watched those already. And this whole section here kind of goes over these measures of central tendency, but it's all summarized right here. Measures of central tendency. So this is what we'll refer to as we work out this problem, right? So first of all, the mean. The mean is the number that is found by adding the data and then dividing by the number of data values. We usually use the symbol X with the bar over the top to denote the mean. Okay? So if I were to apply that to my problem here, it means we add up the numbers and we divide by the number of numbers. Okay? So let me get set up here. Okay. So what we're going to do, we've got the mean, which is oftentimes also denoted by X with a bar. Okay. And we start by adding the numbers together. So 13 plus 8 plus 11 plus 16 plus 11 plus 31. And that sum of numbers is divided by the total number of numbers. There's 1, 2, 3, 4, 5, 6 numbers, so I divide by 6. If you add up those numbers, they add up to, sorry, I don't actually have that sum, so 13 plus 8 plus 11 plus 16 plus 11 plus 31. They add up to 90. Okay, and divide by 6. And that equals 15. Okay, so that is the mean. The next one it asks you to find is the median. So let's come back over here to our textbook and look at the definition of the median. The median is the middle number when the numbers in the data values are arranged in order of ascending size. If there are two middle numbers, in the case of an even number of data, the median is the mean of the two middle numbers. So coming back to our data set, what that means is we have to first start by taking our data values and arranging them in order from smallest to largest. Okay, so if I look at this, I see that the smallest number is 8. And then I have two 11s, and then I have a 13, and I have a 16, and a 31. Okay. The median is going to be the number right in the middle of the set of arranged or ranked data. But in this case, because we have an even number of data values, specifically 6, there are two numbers right in the middle. Right? 11 and 13. So when that happens, the median is found by taking the mean of the two middle values, which means we add them up and we divide by 2. So the median is equal to 11 plus 13 divided by 2, okay, which equals 24 divided by 2, which equals 12. Okay. And then finally, the last value that we are asked to find here is the mode of the data set. So let's once again go over here and look at the definition of the mode. The mode is the value that occurs most frequently. If no number occurs more than once, there is no mode. It is possible to have more than one mode. So if I come back over here, what I see, and it's even more clear if I look at my arranged data, what I see is that the number 11 occurs twice, right? But every other number in the data set only occurs once, right? So the number 11 is the number that occurs the most frequently, so that would be the mode. So the mode is 11. That is how you would do that problem. Okay. The next one you had asked about was problem 25. So let's go down there. Find the standard deviation rounded to the nearest unit for the data indicated. So what we have here is a table of values, right? We have 90, 80, 70, 60, and 50. And the frequency is just how many times that data value occurs, right? So the number 90 occurs twice, the number 80 occurs 4 times, 70 occurs 8 times, and so on, right? The total number of numbers that we have is found by adding up these frequency values. 2 plus 4 plus 8 plus 6 plus 3. Those add up to 23. So we're really talking about 23 data values, right? But only 5 unique values, right? The number 90 repeats 4 times, the number 80 repeats, the number 90 repeats twice, the number 80 repeats 4 times, 70 repeats 8 times, and so on. And we are asked to find the standard deviation. So I'm going to switch back over to our textbook, and in our book there is a step-by-step procedure that we will follow to find this. Got to move forward. This is measures of dispersion. Again, watching these videos would probably be helpful. Measures of dispersion are the range, variance, and standard deviation. And down here we have the steps that we would follow to find a standard deviation. Okay. So what we'll do is we will walk through these 6 steps for our data set. Step 1, determine the mean of the set of numbers. Okay. So the mean, like we saw in the earlier problem, the mean is found by taking the sum of the numbers and then dividing by the number of numbers. Get a blank spot here. So to find the sum of the numbers, we can do it like this. We'll just say mean. We have to remember that these values have a frequency attached to them, right? So we can't just add up these numbers, we have to factor in the frequencies, right? So we have 90, but 90 repeats twice, so we'll multiply it by 2. 80 repeats 4 times, so I'll multiply it by 4. 70 repeats 8 times, so I will multiply it by 8. 60 repeats 6 times, so I'll multiply it by 6. And 50 repeats 3 times, so I'll multiply it by 3. The total number of numbers is found by taking the sum of the frequency values. Right? 90 occurs 2 times, 80 occurs 4 times, 70 occurs 8 times, 60 occurs 6 times, and 50 occurs 3 times. Okay. So if I work this out, if I multiply these, 90 times 2 is 180. 80 times 4 is 320. 70 times 8 is 560. 60 times 6 is 360. 50 times 3 is 150. If I add up these numbers on the bottom, they add up to 23. Okay. If I add up these numbers on the top of the fraction, they add up to 1,570. That's divided by 23, and that works out to be about 68.3 for my mean, rounding to 1 decimal places. Good idea. So, okay, that was step 1. Step 2, subtract the mean from each number in the set. Okay, so what I need to do is I've got 23 values, right? But there's a lot of repetition, so I need to take the mean and subtract it from each unique value. So let's do that. I'll start with 90 minus 68.3. That equals 21.7. And then 80 minus 68.3 equals 11.7. And then 70 minus 68.3 equals 1.7. And then 60 minus 68.3 equals negative 8.3. And then 50 minus 68.3 equals negative 18.3. Okay, that's step 2. Step 3, square each of these differences. So now I'll take each of these values that I just computed and I will square them. Okay, which squaring just means multiply it by itself. Right? So 21.7 squared, and this is just best to use your calculator for this. This works out to 470.89. 11.7 squared equals 136.89. 1.7 squared equals 2.89. Okay. Negative 8.3 squared equals 68.89. Negative 18.3 squared equals 334.89. Okay, so we've squared all of those. Let's look at the next step. Okay, find the sum of the squares of the differences. Okay, so that means I need to take all of these squared values and add them up. But again, we have to remember that these each of these repeat corresponding to the same frequency values up here, right? So when I add them up, I got to remember that 470.89, that corresponds to 90, so that repeats twice. Okay, 136.89 repeats 4 times. So I'll multiply that by 4. 2.89 repeats 8 times. Okay. 68.89 repeats 6 times. And 334.89 repeats 3 times. Like so. Okay. When I multiply these, I will get 941.78 for the first one. 941.78 547.78. 547.56 for the second one. And then 23.12. And then 413.34. And then 1004.67. Okay. And when I add these together, they add up to 2930.47. Okay. So coming back over to our set of steps, we have just found the sum of the squares of the differences. Step 5, divide this sum by one less than the number of pieces of data. And this will give us the variance of the sample. So let's do that. Here's my sum. When we found the mean, we determined there's a total of 23 pieces of data, right? So I want to divide by one less than that. So it would be 2930.47 divided by 23 minus 1, or 2930.47 divided by 22, which equals about 133.203. Okay. Coming back over here, we just completed step 5. Step 6, the final step, take the square root of the variance. This is the standard deviation of the sample. Okay. So I take the variance I just computed was 133.203. So the standard deviation, which I'll just abbreviate as SD, that equals the square root of 133.203, which works out to be about 11.54. But if you look at the problem description, it says rounded to the nearest unit, so that would be rounded to the nearest whole number. So that rounds to 12 when you round it to a whole number. So that's what you would enter in. Okay. So it's a little tedious, but if you follow those steps very carefully, you should come out with the right answer there. The last one you asked about was 26, which is down here at the bottom. This one's about percentiles. When you take the Scholastic Assessment Test, or the SAT, your score is recorded as a percentile score. If you scored in the 92nd percentile, it means that you scored better than approximately 92% of those who took the test. Right? So that's what a percentile is. It compares your score to everybody else who took the test. Right? Part A, if Linda's score was 87, and that score was the 23rd score from the top in a class of 260 scores, what is Linda's percentile rank? Okay, let's see, make some room here, up here. So what we see here basically is that if she was the 23rd score from the top, then we want to figure out how many scored below her, right? And that is found by taking 260 and subtracting 23, and that equals 237 who scored below, right? And we want to express that as a percentage. So we'll take the 237 and divide by the total. And to convert that into a percentage, we multiply by 100. And we want to round to the nearest whole number. That comes out to be 91. So that puts her in the 91st percentile, which means that she did better than 91% of people who took the exam, right? Or we could also say that 91% scored below her, right? The next one, Lee has received a percentile rank of 87% in a class of 60 students. What is Lee's rank in the class? So 87% means that 87% of the 60 students scored below Lee, right? So let's take that percent and convert it into a value. So I'm going to take 87% and multiply it by 60. And to do that, I need to express 87% as a decimal and multiply by 60. And if I round to the nearest whole number, that becomes 52. So that means that 52 students scored below Lee. And that leaves 8 students remaining. So that means that Lee would have been in the 8th rank, right? Because Lee would have been, Lee's score would have been just above this 52, right? There were the 52 that scored below Lee, and then Lee would have been 53rd or 8th from the top, right? Does that make sense, right? Because 52 plus 8 equals 60. So Lee's rank would be 8. So I hope that helps, and please feel free to reach out if you have any further questions. Thank you.